Hello. Yes, in this video I will be explaining how to carry out question number 2 of the 2025 Waec physics practical, and the practical is all about refraction of light waves. Now these are the apparatus you need for this number 2. Number 1, we have the rectangular glass prism. Number 2, we have the drawing paper. We have the drawing board. We have optical pins. We have top pins. But in place of drawing board, you can actually use what we call particle board. Alright, before I carry out the practical, I would like to tell you one advantage that you have if you choose this number 2 question, because on the examination day you have to answer 2 questions out of 3. Now, one advantage you have when you choose this particular number 2 question is that refraction of light waves is not prone to technical fault from the apparatus. Compared to practical like electricity, the cell may not be accurate, the voltmeter may not function well, the ammeter may not function well, and this might affect your readings. But here you are not prone or susceptible to technical errors from the apparatus. Now, as you can see, this is a rectangular glass prism. These are the optical pins. Okay, these are the optical pins, all right, that I'm going to use for the experiment. And here we have the thumb pins that we're going to use for the experiment. Now, this is the drawing paper, and of course this is what we call particle board. I'm going to attach this paper to the particle board. Now, we are using the particle board because the surface is soft and it will enable your pin to be well erect. So, that said, let's cut right to the chase. But before then, make sure you have a complete mathematical set to carry out these experiments. Now, this year's number 2 physics practical experiment has been brought out in Waec before, and I would like to show you the year before I continue. You can verify that yourself on your own. So let me show you the year before I continue. Now, this is Waec practical question 2010. You can see this is number 2. You are provided with a glass block, plane mirror, and optical pins. Place the and so on and so forth. You can see. So this is what I will work with in generating my table of values. Now, you have to place the rectangular glass block on a drawing sheet and trace its outline ABCD as shown in the diagram above, which is this diagram. Now, I'm going to pick my rectangular glass block, place it here, then with the aid of my pencil, ensure your pencil is well sharpened. With the aid of my pencil, I'm going to draw out the outline as the question specified. Make sure your glass block is straight. All right, so I'm going to draw this outline. Okay, I'm going to draw this outline out. Okay, all right, here we go. This is the outline. A, B, C, D. A, B, C, D. Now, the next instruction, remove the glass block, which I've done, and measure and record the width of the block. Measure and record the width of the block. So with the aid of your ruler, you're going to measure the width of the block. which in this case is 5.8 centimeter. So you write it out: width of the block is 5.8 centimeters. Now, having done this, you go to the next. Draw a normal ON to DC at a point about 1/4 the length of DC. Now, the first thing to do here is to measure the length DC, which in this case is 10 centimeters. Now, the question says you should draw the normal ON at about 1/4 of the length of DC. So that means 10 centimeters divided by 4. And if you divide 10 centimeters by 4, you have 2.5. So you put a dot there, then you draw your normal this way. So this is our normal ON. Now, draw a line making an angle of I equals 10 degrees with the normal. So you have to measure the angle with the aid of a protractor, which is this. So you place your protractor this way, ensure it is aligned, ensure the normal is at 90 degrees, then you measure 10 centimeters. This is 90, then to 80 it is what? 10. So you dot that 80, then with the aid of your ruler you draw the line MO as the question specified. Now, this is your I, which is I equals 10 degrees. Now, having done that, you go to the next thing. We place the glass block on its outline and mount the plane mirror vertically behind the block such that it makes good contact with the face AB. So this is what you're going to do. You place your mirror, your rectangular glass block on the outline this way, and you mount this plane mirror. You mount it vertically behind the glass prism. Let it align with the face AB. So having done that, stick two pins P1 and P2 on the line MO. So this is a line MO. So you have to fix two optical pins this way. This is one, and this is the second one. Now, one precaution you should take note of here is that your pins must be well erect. They must be what? Well erect, so that you can get accurate readings. So the next instruction, of course, this is P1 and P2.
Do you see Mr. Falabi?
So this is P1 and P2 on the line MO. So looking through the face CD, stick two other pins P3 and P4 such that they appear to be in straight line with the images of pins P1 and P2 seen through the block. So this could be a bit confusing to some students, but I will try as much as possible to make it clear so that you won't be confused on the day of your exam. Sorry, I have to fix this so that the paper won't shake. So here we go. So you come here, you look through the face DC of the prism. Now you can actually see the images in the plane mirror, but that is not what you have to trace out. You have to trace out the images you can see through the rectangular glass prism, and you place two pins on a straight line with the images of P1 and P2 you can see through the prism. So here we go. This is on a straight line with the images, and you also place this on a straight line with the first pin you put there. So as you can see, we have our P3 and P4 now. So having done that, you remove your plane mirror and your prism. Then join P3 and P4 with a straight line and extend it to touch the face CD at O. So this is P3 and what? P4. So what do? You join P3 and P4 to join the face CD. So I've joined P3 and P4. Now draw a perpendicular line from the midpoint of OO to meet AB at Q. So this is another point O. So draw a perpendicular line from the midpoint of OO to meet AB at Q. So you are going to measure from the first O to the second O, which is 1.5, and the midpoint of 1.5 is 0.75. So you come here, you measure 0.75, you put a dot there. So you draw a line to meet AB at Q. So this is point Q. Having done that, draw lines OQ, OQ, and normal ON produced. So you draw this line from here to meet this point O, and you also draw this line from here to meet this second point O. So having done that, you draw a normal to the second O. Alright, that is the normal. Now this angle here from the diagram is angle E. Is angle E, and the distance from here to here is D. Now the question says measure and record E and D. This Q is a mistake from the people who compiled the past question. It is actually measure and record E and D. So with the aid of a ruler, you come here, you measure from here to here. Our D is 1.5 centimeters. Then our E is. So with the aid of this protractor, you measure your angle E. Ensure that it aligns with angle 90. So this is 10 degrees. 10 degrees. Now, what the practical question will ask you is to do or repeat the procedure for different values of I. I have done 10 degrees. It will ask you for 20 degrees, 30 degrees, 40 degrees, and 50 degrees. So I am going to do for these 4 other values of I, then come back in the video and show you how they look like and the readings I got.